Guys, let's talk about new problem from graph, which is called find cheapest flight with k stops. Okay, so what you have given, let's say you have given graph something like this. So this is your zeroth vertex. Okay, this is your first and this is your second, which are the stoppage actually. Okay, so from this is your adjacency list. So from 0 to 1, okay, the weight is 100, means the cost go from 0 to 1 is 100, and then from 0 to 2 it is 500. Okay, second stoppage, and then for 1 to 2 it is 100. So you need to go from source to destination in k stoppage. Okay, so this is the graph is given, and let me shift it a bit here. Okay, now see, the structure of the pair will be something like this. We will use here two things. One is pair, second is tuple. Okay, so pair we will use to store in an adjacency list. Okay, so you would be given 2D array, like flights 2D array. So first you will create adjacency list and you will store pairs into that. Okay, so node and coast, and then you will be using queue. Okay, because we will be using here Dijkstra algorithm. So the queue structure will be in tuple format. So what will be the tuple? Stops, node and cost. Okay, so when your stop is equivalent to k, you will stop the searching. Okay, so now what you will do first, let's see, this is the graph is given to you, and then you will first create adjacency list. Okay, so what you will do, you have given 2D array, and you will create array list of array list, okay, of type pair, and you create a array list, and then you assign a memory. Okay, and then so the flight is something like this, the 2D array, okay, of which has 3 columns and multiple rows. So in our case 3 row 3 column. Okay, so this is, let's say this is flight, so this is your flight 0, flight 1, and this is f2. Okay, the column name. So the f0 is something like 0 is connected to 1 here. Okay, if you see this adjacency list, this one will be f0, this one will be f1, and this one will be f2. F2 will be the cost. Okay, and f1 will be the other node. So now so how you're creating adjacency list, get f of 0, you will add a pair into that. Okay, something like this. Okay, so now let's dry run first. So you will create a distance array, okay, of size vertices. Let me remove it. So first you will create a distance array of size vertices. How many vertices do you have? 3. Okay, so 0, 1, 2, and now you will initialize it with infinity, and the first one will be 0 because this is your source node, and you have to go from 0 to 2, okay, in one stoppage. So k is equal to 1. This one is your source, this one is your destination. Okay, now here let's create one queue as well. Okay, so queue will store tuple. Now what will be there in the tuple? First one will be your stop, second one will be your node, okay, and third one will be your cost. So this one will be the tuple you will store in a queue. Okay, so now let's start. So this is src is 0, and you have added in a queue source is 0. Okay, sorry, stop is 0. First time the stoppage is 0 and the source is 0. Let's say you have to go to 2. Okay, and then by k equal to 1 stop. So initially your stop is 0 also as well. Okay, now let's take this value from q. So let's end then what is the, so 0 you have added, okay, in a dist array. This is your dist array. Now let's traverse all its adjacent neighbors. So who all are adjacent of 0? 1 and 2. Okay, 1 and 2. So I know that see, this is my cost. Okay, to reach till 0th stop, okay, the cost is 0 and stop is 0. Okay, so now what will be the cost for to reach 1? So it will be 0 plus 100, whatever cost I have here till reach 0, and plus 100, right? So to reach till 1, the cost is 100, and the current cost in the dist is infinite. So infinite is greater, so I can replace it with the lower value. Now as I have added this value into the dist array, I have to add this into my queue as well, right? But with the stoppage k plus 1. So current stop, the earlier one was 0, so now this one will 1. What is the node? 1. We are going to towards 1, and then what will be the cost? It is 100. Okay, now let's talk about the second neighbor. So 0's second neighbor is 500. So 500 plus 0, new distance will be 500. Okay, add this value into the queue. So stop is again 1 here. Okay, 0 plus 1, and then the neighbor is 2, and then the distance is 500. Okay, now let's take this one 1 comma 1 comma 100 out of the queue. This is normal queue, not priority queue, just normal queue. Okay, so now because you are adding k plus 1 and you're starting from 0, so you don't need priority queue. It will automatically store in a correct order. Okay, first 0, then 1, then 2, and anyways it is FIFO, first in first out, so you will take the lowest one only. Okay, initially. So now it's time for 1 comma 1 comma 100. Okay, 1 comma 1 comma 100. So now here 1 is a stoppage, okay, node is 1 and 100 is the distance. So who all are neighbor of 1? So 0 and 2, right? Let me remove this one will create confusion. So 0 and 2. So let's check for 0, okay. So to reach till 1, the distance I am taking is 100, okay. And again, if I go from here to 0, it will be 100 plus 100 means 200, and my current distance for 0 is 0, so I don't need to replace it. And if I'm not replacing it, I don't need to add that into my queue as well, right? Now the second node of this 1 comma 1 comma 100 is 2. So the distance till 1 is 100, and if I need to go from 1 to 2, it is again 100, so 200. So here current one is 500, so I can definitely replace it with 200, okay. So now I have to add this value into my queue as well. So now my current stoppage was 1, so now it will become 2, okay. And then node was 2, okay, and then distance is 200. It's time for 1 comma 2 comma 500, this one, right, this entry. So 1 comma 2 comma 500. So who all are neighbors of 2? 2's neighbor are 0 and 1, okay. So let me remove the earlier one, and 0 comma 1. Let's check for 0 comma 1, okay. So if I check for 0, so to reach till 2, I'm taking 500 distance, and if I need to go from 2 to 0 again, I need to take again 500. It is 1000. No value in taking that, okay, no advantage. So now let's see for the 1. So for 1, it is till 2, it is 500, and then plus 100, it is 600, but I already have 100, so I'll not replace it, okay. This one is also done. Now it's time for 2 comma 2 comma 200, okay. So here one thing also you need to check, if your stop is greater than k, then just continue, okay. So now here my stop is become 2, k was 1, right? So I'll continue it, so I'll not process for this one. Now my queue is empty, so whatever dist I have, I will return that. So my answer is 0, 100 and 200. 0, 1, 2, right? Means from 0, I'll take this 0, 1 and then this 2. So this is 0, 1 and 2. This 100 and 100, this path I'll take, okay. So this one will be my shortest path. That's it.